All right. So yes, welcome to the introduction to PySC2. For those who don't know who I am, Stephen Brown. I'm the second highest code contributor to the PySC2 framework. So these guys here are all DeepMind guys, and I'm not. But I'm number two. And mostly because I wrote a lot of code, not necessarily because it was good stuff, but it made it in. So I'm pretty proud of that. I created a feature called feature units, which is the one I use pretty much primarily. And it kind of has some things that I saw were missing, so I added it, and they said, bring it on in. And here's a bot of mine. Let's see if I can get it to full screen. Sorry. Hit the button behind there, the on-screen display. Get it working. Should have moved it up. So this agent was using Q tables, very primitive form of machine learning. And I had an agent that was responsible for producing units, an agent that was responsible for finding the enemy on the minimap, and then an agent that was responsible for deciding if there's an enemy on the minimap, which one am I going to attack that's going to give me the biggest reward. The building placement is all coded in, so in order to simplify it, I've coded that in. It really just gets crazy, you end up with buildings everywhere and all sorts of stuff going on. So it's one of those things that I sort of experimented with and went, I'm going to just put these here, make sure I can do that right, and add the machine learning in other areas. So let's see if we can. So you can see it's got quite a few buildings there, moving out across the map. And then running around randomly for some reason, because it thinks that the enemy is possibly going to be down there. It turns out that sometimes it is, because that tends to be an attack path that the enemy takes on its way in. Okay, so here it is, coming back to defend and attack. Now, as you can see, it's designed only really to have Marines, so that's kind of what it's pumping out at the moment to win this match. Now we've got an expansion. That's kind of cool stuff. And they're programmed in as well. Hasn't learned that yet. Towards the end so we can see. Here it is making its way into the enemy base. It decides to attack the rocks for some reason, not really sure why. Doesn't want to go up the ramp. Just wants to hide. So you can see it gets a little bit confused when there's enemy bases that are far away from each other. It gets a little bit confused and goes, oh, I want to attack that one, no, I want to attack that one, no, I want to attack that one. There it is. So that was against the harder AI. So that's it's fairly high up in the skill level for these things. If you want to find me and more information, I write a lot of tutorials on Medium. That's kind of my main source. And I stream sometimes on Twitch, like I am now, and I take donations on Patreon. So that kind of helps me pay for things like getting an Uber to the airport so I can come down here and that kind of stuff. So let's get into it. What is PySC2? PySC2 is a Starcraft 2 machine learning environment. I assume everybody here knows what Starcraft 2 is and what machine learning is. It interacts with Blizzard's Starcraft 2 APIs. So DeepMind and Blizzard work together to sort of develop this API. DeepMind was working on the machine learning side, and Blizzard worked on plugging it into the game. It's Python based. Basically, that's what a lot of DeepMind stuff is built in. You've all heard of TensorFlow. It's designed to emulate the human abilities. So there's some sort of limitations that they built in. For example, it will only take one action at a time, even though the API supports multiple actions. And it can only observe certain things, even though the API supports information on all sorts of hidden unit information and unit IDs and all sorts of crazy stuff. It's backed and developed by DeepMind. There's actually a guy called Timo, a developer from DeepMind, who pretty much is the lead engineer and writes most of the code. And it's available here via GitHub, and also you can use pip install PySC2 to get to it. So the GitHub repository is kept up to date, and it's far more ahead, more advanced than the pip version. So what is the Starcraft 2 API? It allows you to interact with the game via something called Protobuf. Apparently that's pretty common, so that's quite good. It has limited Linux support, so although the game is built for Windows, it does have Linux support, mainly because DeepMind is operating most of the machine learning on Linux. It can play replays. It provides the ability to investigate the game state, so it can tell you lots of information about the game that maybe a human has access to, maybe a human doesn't have access to. It has the ability to perform actions, so I want to attack, I want to build a marine, that kind of stuff. It supports 2 players at the moment. They didn't really want to get caught up with multiplayer 2v2s or 4v4s or anything like that. It has some limitations. It has a lot of limitations, but it's also quite good. I'm going to point out a lot of limitations, but I don't think that's a negative. It's just sort of, these are things you have to keep in mind as you're working with it. And it's still being developed. It's being developed all the time, so there are always commits going into the GitHub repository by DeepMind, and there are always commits going in from Blizzard. But of course, there's pretty much just one guy working on this from the Blizzard side. So they had a big team initially that were involved, and now it's down to pretty much one guy, maybe 2 guys. So and he's sort of 50% of his time's on this. So things do sometimes lag behind a little bit. There are some alternatives to PySC2 if you're not really into Python and you want to sort of experiment with something else. Dave Churchill's Command Center is a C++ framework. It was originally developed for Brood War, and it has been adapted to Starcraft 2. It's very popular. It's used a lot for just straight up bot battles. So if you don't want to do a lot of machine learning, you just want to script a bot, that's a really nice place to start. It's got a lot of utilities, it's got a lot of stuff built in, very easy to use. Python SC2 is essentially an interaction into the framework, the API, without the human realistic limitations that DeepMind has put on it. So you can get access to some pretty cool stuff, you can take a lot more actions, so potentially there's some stuff there that you could do that's may not emulate what the player is able to do, but might help you build some other structures. And there are a whole bunch of other ones like C#, Clojure, Java, Go. I think there's even a JavaScript one. So there are quite a few out there if you want to interact in your language of choice. So why would you choose PySC2? Well, mainly because it's got Python in it. So you can use TensorFlow, you can use scikit. Most of the machine learning stuff that you're going to get out there is Python-centric, so being able to leverage that is always going to be a benefit. DeepMind is behind it, so some of these other frameworks might come and go, they might sort of lag in development. DeepMind's sort of pretty heavily invested into this, so it's going to be developed for quite a while to come. If you want to build a human comparable bot, this is probably the way to do it. They've already built in the limitations for you, they've already provided the framework to do that for you. And this is my personal life. You can't stand the thought of interacting with other humans or having any spare time, or you want nothing to do, you want to do nothing but code bots all day, which is kind of what I've done for the last year since I discovered this. So that's kind of a bit of a stress, a personal stress. Why would you want to code for Starcraft 2? It's deterministic. So one of the main things about the game, if you looked at the replay files, they're very, very small. That's because in a certain state, if it takes a particular action, that action always produces the same result. So there's no random chance, there's none of that sort of stuff going on. So, you know, if you want to attack and you shoot at this point in time, it's always going to shoot and it's always going to do the same amount of damage. There's an extremely large state and action space. And by extremely, I mean really, really, really big. So, you know, hundreds of thousands of millions of billions of possible states and actions that you can deal with. So it takes a lot of time to explore and find out what works and what doesn't. So that's why DeepMind have chosen it. They've gone, well, that's a really hard problem, why don't we tackle that? There's also hidden information. You don't know in StarCraft 2 what your opponent is doing. You don't know where they are, if it's behind the fog of war. You know, a game like chess, you can see your opponent's pieces. You can't see what he's thinking, but you can see his pieces. Everything's laid out. So when the board looks a certain way, you tend to have a pattern for how you're going to react. When you can't see half of that board, what would you do? So that's kind of the challenge that's here. One thing that you're going to have to decide if you're going to get into developing with PySC2 or one of the other frameworks is what sort of agent do you want to build? Some people go with completely scripted. They just want to script the bot. It has a build order. It goes and attacks. It does certain things a certain way, and that's quite cool. You know, there's a bit of that around. Partially scripted and partially machine learning is kind of where I'm at. Mainly because I've got one little laptop here. I don't have a server farm, and I want to sort of experiment with the smaller pieces of it and see how I can get machine learning to, for example, find out what's the best place to look for the enemy on the minimap. You can go with completely machine learning, but structured specifically for StarCraft 2. So OpenAI is kind of doing this with Dota. Their whole structure of their machine learning is built pretty much for Dota. It might apply to a game that's like Dota, but it's generally, if you picked up this the Dota 2 structure and you applied it to Doom, it's not going to work. So a lot of what DeepMind's doing in the next point, they're essentially trying to get one structure that works across the board. So they can just, here's a new game that came out, here's the structure, go, and just see what happens. So this is the main game engine, the game flow. As I pointed down there, remind you of anything? This is essentially the state, action, reward structure that you would have in any machine learning. So state being observed, and here's your reward at the end. And this is an agent that basically does nothing, but this is a simple code. It extends the base agent. You can set up whatever you want at the beginning. The init method there is probably where you're going to create all your networks, initialize them, load any previous learning, that kind of stuff. Reset happens after every game. So that's where, or before each game, so that's where if you've got a bunch of things in memory, you might want to clear those out, reset them and say, okay, let's start fresh. Step is really the key part. Step is where everything happens. So every time you take an action, you land back at step, and it says, here's where you're at, now let's take another action. So you always have to return an action at the end. If you don't return an action, it just explodes. So let's start at creating a game. The main game options that you've got, the map that you're going to play on, the players who are going to play the game, the screen resolution and the minimap resolution. I've simplified it quite a bit here, but those are kind of the core things that you're going to need to get started. And this is kind of what it looks like. So you can see up there I've got a map name of Simple64. The first player is my agent, and it's going to play as Terran. The second player is the bot, the built-in bot. It's a Zerg bot, and it's easy. And then you've got this agent interface format, and this sort of allows agents of different interface formats to play against each other. So if you've got one that uses a higher screen resolution, a higher minimap resolution, it can play at its resolution, and then another agent can play at a different resolution. So you feed in the screen resolution and your minimap resolution, those are the defaults. And then you've got an action space, which will come a little bit further on, but that's the default there. So in terms of maps, there are some maps that DeepMind has developed for their initial testing, and these have been quite popular for testing algorithms. And this is kind of where most people start. If they've got an algorithm, they sort of want to play around. The map names are fairly self-explanatory. I'll just play this video of DeepMind's bot playing. So you can see in the top left, it's just basically it's just got to learn to move to that beacon. Top right, you just got to collect stuff. That's not really that difficult. The game does most of that for you, but it turns out there are some optimizations that you can apply if you have the ability to act quite quickly. You can actually collect minerals and gas faster than the built-in game. Bottom left is quite cool, collecting mineral shards. Essentially just kind of a vehicle routing problem, if anybody has dealt with that, or travelling salesman problems. And the bottom right is build marines, which interestingly is actually the toughest for the DeepMind bot to play. It turns out it's not very good at optimizing for building marines. That might have changed. We'll see. There's also melee maps, and these were built by Blizzard. Essentially just simple versions of maps so that you can test your bot out on the full game, but not on the full map, a large complicated map. The names are kind of self-explanatory. You've got some flat ones. The simple ones are kind of what I tend to use when I'm testing things out. 64 is very small, just a couple of bases, and they go up from there. They're actually quite well crafted. I believe it's the simple 128 has a big band through the middle that you can't walk through. And your bot kind of gets a little bit confused as things walk around it and they spread out and that sort of stuff. So there's some good little terrain challenges in there that you can sort of test your bot with. And last but not least, the usual ladder maps. So everything that everyone's playing, you're seeing on any of the Twitch streams and all the WCS tournaments, they're available there. However, they can lag a little bit because the Linux version of the game is locked at an older version. So a lot of the newer maps need newer functionality from the game in order to work. The ladder maps are very complex. So if you're trying to train an agent on one ladder map and then you want to throw it on another one and expect it to just work, it probably won't. The base locations are different, the mineral locations are different, the terrain's different. Some of them are rectangular, some of them are square. Some of them you start in the corner, some of them you start at the top. So things can be quite different. So that's really, really complicated stuff. Bot difficulties, not a whole lot to say here, except that the names that you can supply don't match what you're used to seeing in the game, just for a couple of them there. Medium hard is actually hard. Hard is actually harder. Harder is very hard, and very hard is elite. So when you hear about people and which level of bot they've beaten, what you feed in may not be the same thing. So you can see that my bot earlier, I believe, was against very hard, which is actually harder. Well, harder, which is very hard. Very confusing. I spoke to the guys and I said, why did you do that? And they said, well, that's what the API supports, and we kind of wish we had just used the in-game names instead of what Blizzard had given us. But it's kind of locked in for all time now. So there are a few more useful game options. Step mul is essentially step multiplier. So the number of steps that you're going to take before you have another observation and before you take another action. In a normal game, so the ladder games are played at 22.4 steps per second for faster mode. So given that, if you feed it a step mul of 8, you'll get around about 168 APM, 168, 180, depends. It seems like it's kind of a hand wavy kind of number. I've actually had issues below a step mul of 2. So I've had issues where you tell it to select something and then in the next step it's not selected yet, but then in the next step it is selected. So there seems to be sort of some little things there you have to be aware of. Just because you told it to do something doesn't mean it necessarily worked. Game steps per episode. This is essentially how many steps do you take before it's all over. So it's a really good way to sort of limit your bot playing for 3 hours because it's just running around the map and it's never going to finish, that kind of stuff. Visualize is a really cool tool when you first start out, so you definitely want to turn that on. What it does is it takes all of the observations, all the information that your bot has access to, and it presents it in a human rendered format. It's kind of different to the game, as we'll see later. So if you're having trouble kind of understanding what your bot can see, turn on Visualize, play it through. However, it will slow things down, so you don't want to be running that all the time. Once you've got it figured out, turn that off and then train your bot. Disable fog is also pretty handy. Once you take that element out of it, once you let your bot see the entire minimap, it doesn't have to guess anymore. So it doesn't have to sort of tell the difference between I walked there and then I saw something, or I walked there and that created enemy that appeared. It's one of those things that's quite challenging for a bot. So if you disable the fog of war, your bot's sort of a bit more stable, it's more predictable. So, some tips when you get started. Start against very easy. Don't start against elite. Everybody starts against elite and everybody loses, and then you step it down and then you step it down and then you step it down and then you get down to very easy and you go, oh, I've got a bug in my code. Okay, now I can step it back up again. Start with very easy and make sure your bot's doing what it should. Make sure it can play enough of the game that it actually learns something and you can see that it worked. Play as a single race. So this is all about reducing variance and complexity. So play as a single race. Terran's usually the easiest. Sorry for Protoss and Zerg people out there. Terran's the easiest, mainly because you can get minerals and you can produce marines. Marines shoot up. Zerglings don't shoot up. Protoss, Zealots don't shoot up. Everything else requires gas after that. So it's kind of the best place to start. Disable the fog of war, as I said, just kind of reduces complexity, makes it a little bit simpler. Use a single simple map. So don't start out by going, okay, I'm going to go on all the ladder maps and we're going to play all of them and I'm just going to go from there. Start with a simple map, start with one of them, train it on that, make sure it works, and then go from there. And just a little tip, human players can beat the very easy AI with an APM of less than 60. So if you have a step mul of 20 to 30, your AI may be able to win with just that. So you might think it's cool to be able to act, 3,000 APM or something like that. Turns out you don't really need to. Maybe you need to get up to a step mul of 8 when you're playing more advanced bots. Maybe you need to go to step mul of 4 in order to beat elite. Maybe you need something more than that. But starting out, just limit it to 20 to 30 and see how it goes from there. It'll actually make your agents a lot simpler. It'll make their learning a lot easier to control. Try and limit the game to half an hour or so. So this is the max steps per episode, 40,320. There are some quirky things. I don't know what they are. The guys from DeepMind just told me. Once you go above a certain length of game, things kind of get a little bit crazy. So you might be better off just limiting it to half an hour or so. Plus, against a very easy AI, you should be able to win within half an hour. So if it hasn't won within half an hour, it'll get a reward of 0. That's basically the same as a draw. So you can then get on with the next game and maybe try something different. So you don't want it to persist. It also kind of gives it a bit more of a fixed timeline. So it's a bit more of a fixed limitation of how many steps there are. So it gets a little bit less complicated. maybe have your agent play against a simple scripted bot. So maybe you have a bot that you build a Zerg bot that builds a spawning pool, pumps out Zerglings, and then when it gets to 5 Zerglings, or probably 10, when it gets to 10 Zerglings, it attacks. And that's all it does. And then it builds 10 more, and then it attacks. Build your agent to play against that because it's a predictable, repeatable enemy that you can play against and make sure that your bot is actually doing what it should be doing. This one's a good tip from DeepMind. Consider self-play. So you get twice the learning per game. If you think about this, you've got your agent on one side and your agent on the other side. One's going to win, one's going to lose. So you get the positive reward's going to flow through, and then your negative reward's going to flow through. So you get twice the value. Of course, you can't use it to measure your win rate because it's always going to be 50-50, but it's quite good. That's what AlphaGo and AlphaZero or whatever they call it, that's basically how they built it. It played against itself. One trick is, if your bot can only do a certain number of things, like it can only produce Marines, well, then it's only going to learn how to play against a bot that can produce Marines. And so it won't generalize to other races and other strategies. And then when you're sort of measuring your success, compare your bot against one that chooses completely random actions. So turn the learning off and tell it to just do whatever it needs to do. And then you can compare the win rate and go, well, if it just does things randomly, what's the win rate? 10%, 15%, 30%? And then if your agent does better, great. If your agent does worse, maybe it's learning something it shouldn't do. Okay, this is going to be the next big one. Maybe we'll take a 5-minute break and people can get a drink of water and stretch their legs, and then we'll come back.